Okay, so let's talk about what the Malt Innovation Center is really about, which is malt. So this is our pilot malting unit. The batch size here is 150 kilos, or about 320 pounds. The barley comes in from the farmer's field, and we clean it, and we steep in is the first step. And that's always the first step in malting. So steep takes about 2 days. The germination takes about 4 days. And then the kiln takes about 1 day. So that's 7 days. So here we go. So we steep. So what do we do in steep? So the barley is added into this tank, and we have water in here. There's a false bottom right here, and below this false bottom, this space is called the plenum. So above the plenum, this is where the grain is sitting, and we add water. These particular blue hoses, they are air hoses. So when we have a little grain, a kernel of barley, we want to replicate the best growing conditions in a farmer's field. So we need it to be warm, and we need it like it's springtime, right? And we need it to have the rain, the water. But kernels of any grain or any seed breathes oxygen just like we do. There is no photosynthesis going on, so it's not acting like a plant. It's not taking in CO2 and giving us oxygen. It actually is breathing just like we do. So we have to be careful that we don't drown those little kernels and seeds of barley. So we will fill it up with the grain and the barley, and we will circulate air through it. We'll just bubble air through it when it's under steep. And we'll do that for about 12 hours, and then we'll drain out the water and just let it breathe and respirate. It needs to respirate, and it will breathe off the CO2. And then the other thing with the water is that keeps it cool, because heat is also a byproduct of germination. So we need to keep it cool. And these blue air hoses, we can control the temperature of this air. We have a tank back here that has both heating and cooling capabilities in it. And so we are cooling the air as we blow air through here, and we're cooling the water that we use as well. So we'll drain the tank, refill it another 12 hours. Most of our malted barleys have about 2 immersions, and at the end of that time, it's another rest period, and that's called a couch. So what's happening during the steep is that we're taking barley that's coming out of the field at about 10% moisture, and we are raising the moisture level to about 44%. And during that time, here's our little kernel. It starts to grow, and it's starting to kick out a little rootlet to pick up some more of the water. And we're really hydrating it, though, is really what it's all about. When we bring it over to germ, this kernel's going to start growing into a tiny little plant, but first we have to get the moisture level up. So we're going from 10% moisture to 44% moisture. We're making sure we keep the kernel alive. It's really important with the barley that we get that it is homogeneous, meaning that it has the same kinds of growth conditions and growth capabilities. So we get barley from all over the western United States. The barley might come from mountainous regions, so that would be altitude grown barley. It could come from sea level. We could also get barley that is dry field farmed, so waiting for rain all the time, or irrigated. Now these barleys are going to germinate at very different rates, so we have to keep them segregated, because truly every farmer's field is like a microclimate. So each are going to have their own type of germination capabilities. Now when the new crop comes in, we will do test batches here, but how is each farmer's, let's say, field of grain going to react? We have to kind of pre-test it. So we know by the time we get through with our process here, we have all sorts of data that we could give the plant, and then our maltsters in the plant, they know, is this barley going to have a difficult time absorbing moisture? Is it going to need more waterings during the germination process? We have an ideal system here, so if it isn't reacting perfectly in our ideal system, how is it reacting during all these processes? And therefore we can let the plant know so that they have like an awesome chance at an awesome result, I guess is the right term. So after we hit our 44% moisture here, we will take the grain out of here, and you might be wondering, how do you get it from here to there? Well, we have a bin hopper that we load, that we put underneath here, and we drop it out of the bottom. And then we have a conveyor, and we'll take this bin hopper, and we'll move it over to our next vessel here, the germination vessel, and we will load it into the top. So the germination vessel, spent 2 days here, now we're going to spend 4 days here. And during this time, what's happening is that little kernel that we have, the rootlet has started to come out, it's taking up moisture, and then we have something called an acrospire, and that's the miniature plant, that's the baby plant. It's starting to grow. Here's our little acrospire, and our goal is to get it between 3/4 and 100% of the length of that kernel. And then we have to stop growth. If we hit it just right, we've maximized the amount of available starches that are available in each kernel without losing any of that starch just to excessive growth that's not necessary. So let me open this up here. This is our germination vessel, and here's the plenum underneath again. And so here's our false bottom. And these are turning arms right here. And so we'll load this wet grain over to here. And so the moisture level stays about consistent for those 4 days. About every 8 to 12 hours we'll turn the turners, because what's happening is these rootlets, if you just let it sit there, these rootlets are starting to bind with each other. And then you can't get loose kernels, and you couldn't even turn these turners if you let it go too long. It would just be like a solid block of concrete, and you'd literally have to chip it out of here. So, during this time, it'll get sprayed with some moisture. Actually, it gets sprayed from below. We have the moisture coming up, and it's warm air. We can control the temperature and how much moisture. We can dial it all in. Everything's digital here. And the moisture comes up through the grain and out through the top. And so we're turning it now and then, and it's growing. So after 4 days, our little acrospire is grown right where we want it. Literally time to kill the plant. Now that does not kill the enzymes that the brewers are going to need, because those enzymes will convert the starches into the sugars that the brewers will need, and the distillers will need to convert the starches into sugars that then the yeast converts into alcohol. So from here, we will once again empty everything out into our bin hopper, put it into our conveyor, and bring it over to the kiln. So, looks very, very similar. But instead of the moistness coming out into the plenum, we have dry air that comes out through the plenum and then circulates up here. And so drying, or I should say kilning, is a two-phase process. Remember the malted barley, it's malted at this point, is moving into here at about a 44% moisture rate. We need to get it down to about 4.5% moisture. So what we have to do is we have to drop that moisture level from the 44% down to 10% slowly. We have to just raise the temperature a little bit above ambient and blow this warmish air through until we drop the moisture level down to about 10%. That's the drying phase. The second phase of kilning is called curing. And at this point, we'll raise the temperature a little bit higher, and then depending on what you do in the cure phase, that's really where flavor is built. So I know a lot of brewers and distillers talk about terroir, and they talk sometimes about we want barleys that are grown for flavor. Well, there's a lot of flavor in barley, period. You compare it to something like wheat or something else. It definitely has its own flavor, but the flavor is really developed in the cure. So depending on how hot your temperature is in the cure, how fast you ramp up, where you are with your moisture levels and your temperature levels and with the heat and the airflow rate, all those things will determine the type of specialty malt that you end up with. So if you want base malt or a Pilsner malt, you're going to start with a very low temperature for the dry and a very low temperature for the cure, and you're going to really preserve both your enzymes and your light color. If you want something like a pale ale malt, you'll let it go a little bit warmer. It'll kind of stew in there, and that'll develop some of the melanoidins in the colors, and that's where your flavor is really coming from. You go a little bit warmer yet, you're getting maybe some Munich malts and things like that. So there's a lot we can do in the kiln itself with the stewing and everything. You can basically make base malts and specialty malts, going from your Vienna malts all the way up to your melanoidin malts. Now, if you want something like a crystal malt, that's where you're taking malt that's basically coming out of here, and you're putting it someplace where it's going to get very hot very quickly. But we have steam capability in both this vessel and our germination vessel. That's something unique to Great Western Malting. And so we make caramel steam malt. Our caramel steam malt is a 40 SRM color, and maybe someday it would be awfully fun to have a whole line of caramel steam malts, 10 to 85, who knows what. But it depends on what breweries and distilleries want. There hasn't been a demand for that, but people are loving our caramel steam malt. And we can make that in a vessel like this that has steam. So at the point we're moving the germinated grain over to the kiln, at that point we introduce steam to drive the humidity and to drive the temperature. So it's always time, temperature, and moisture. And we bring it to saccharification temperature with moist heat instead of the dry heat in the Probat roaster. And we hit our saccharification temperature, and then we roast it off in here with this moist heat. And that's how we make caramel steam, and it's pretty awesome, actually. We have a lot of interesting malts that we develop in the Malt Innovation Center here. We have tiny equipment, like we have a tabletop coffee roaster that we modified to be a little test roaster for our malted barley, and we experimented with biscuit malts. We have a biscuit rye that we developed. It's available right now through Country Malt Group, and there are other things that are really cool that we are able to do with this equipment because it is so unique, this equipment. We had two experienced maltsters basically design into it what they wanted to see, and it's super flexible. So we built this 150 kilo unit, and I gotta say, the malt that we put out of here is pretty fun and delicious. So that's our pilot malting unit. Well, thank you for joining me. I'm Terry Ferendorf, the Malt Innovation Center Manager here at Great Western Malting Company. It's been lovely to have you along for our tour. See you next time.